We're going to continue our introduction to algebra, moving from expressions, now looking at equations. And remember the big difference between an expression and an equation. An equation is going to have that equal sign. As soon as we see the equal sign, now we have an equation. And there's also a difference in what we do. As we talked about, we evaluated expressions. Now we're going to solve equations. And what you're doing when you solve an equation is simply finding the missing number. What does the variable have to equal for that equation to equal what we want it to be? So let's look at some examples. Now, the thing I'll point out here with these is while many of these maybe can be done mentally or at kind of that introductory level, I'm going to start showing and I want you to start practicing how to do these mathematically because we're going to look at it very soon balancing two-step equations and equations with fractions. So get in the habit of thinking about, yes, I know this is the answer, but why? So let's look at the first example I have here, which is 6y equals 24. 6 times what equals 24? Now you may already be saying, I know that 6 times 4 equals 24, so y has to equal 4, and you'd be correct. But remember, the way we show that is 6y divided by 6. The opposite of times is divide. We solve an equation by working backwards and doing the opposite. Remember, fraction bar means divide. So what we have right now is 6y divided by 6, the opposite of times 6. And we know to keep things balanced, anything we do to the left side of the equal sign, we also have to do to the right side. So what I'm ultimately doing to solve this equation is 24 divided by 6. And I know that 24 divided by 6 equals 4, and that is why y equals 4. And that's the way it looks if you show your work mathematically. Let's look at another example. I have a fraction bar 3 equals 9. Remember, fraction bar means divide. So I have a divided by 3 equals 9. Now, think about backwards. What's the opposite of divided? The opposite of divided by 3 is times 3. So I'm going to multiply by 3 on the left side. And to keep things balanced, anything I do to the left side, I have to do to the right side. All right, so I get 9 times 3 equals 27. A equals 27. And the nice thing about these problems is you can always check your work very quickly. All right, if I look at A equals 27, well, put 27 in place of A. Is 27 divided by 3 equal to 9? Yes, it is. So A must be 27. Next example is x divided by 6 equals 9. What's the opposite of divide? The opposite of divide is times, so I'm going to go times 6. And anything I do to the left side, I have to do to the right side. So I have x equals 9 times 6 is 54. And once again, I can check my work. Put 54 in place of x. Does 54 divided by 6 equal 9? It does. So x must be 54. All right, number 9 over here says 48 divided by 12 equals x. What does x equal? This is a little bit different one because the x is already by itself. My goal in balancing equations is always to get the variable by itself. In this case, the variable is already by itself. So I really do just have to do 48 divided by 12, which is 4. So x equals 4. You will see those occasionally, not real often. A couple more examples here. H minus 12 equals 24. All right, I'm looking at h minus 12 equals 24. The opposite of 12 minus 12. I want to get the h by itself, so I'm going to do the opposite of minus 12, which is plus 12. And anything I do to the left side, I know to do to the right side. So I have h minus 12 and plus 12 balance each other out, cancel each other out. I have 24 plus 12 equals 36. So h has to equal 36. Next, I'm going to look at number 11 here. 19 plus y equals 28. I have to look, first of all, what's the operation in the problem? Is plus. The opposite of plus is minus. So I'm going to subtract. The opposite of plus 19 is minus 19. And anything I do to the left side to keep things balanced, anything I do to the left side, I need to do to the right side. So I'll subtract 28 minus 19. And I should have y equals 9. And if I check my work here, I can put 9 back in place and do 19 plus 9. Does that equal 28? It does, so my answer must be correct. The last thing I want to look at with you here is reading a word problem and being able to write your own equation for the situation in the word problem. Right? So this says Aaron wants to buy a video game. The game costs $15.50. He has $10 saved from his weekly allowance. How much money does he need to borrow from his mother in order to borrow the video game? The tricky part with this is that students always want to go straight to the answer. I want to find out how much money Aaron needs, so I'm going to do 1550 minus 10. And while that's correct, you're skipping a step and getting straight to the solution. I want you to write and solve an equation, as the directions say. So what does our equation look like? Well, we know that he's starting with $10. So we're going to call that our starting amount. Okay. We also know that he needs to get to 1550 in order to be able to purchase the game. So we need a total of 1550. As you can see, he doesn't have enough money. So he needs to add some more money. I'll put M for money. He needs to add some more money to his savings so that he has $15.50 or enough to buy the video game. So this is my equation that demonstrates that situation. I have the $10 I'm starting out with. I'm going to add some amount of money until I get to $15.50. Now I'm ready to solve this equation. As I look at it, what's the opposite of plus? The opposite of plus is minus, so I'm going to subtract $10. And anything I do to the left side, I have to do to the right side. So I'm ready to balance this equation out and say M equals $5.50. So the amount of money that Aaron needs to save yet is $5.50. That's an example of writing your own algebra equation to describe the situation and then using your equation to find the answer. All stuff that you'll do and get lots of practice with throughout the year as we continue to look at algebra and writing and solving algebra equations.